How you doing today, guys? This is Alex Gomez, your favorite teacher in the whole world. Today we're going to talk about theoretical probability of compound events. Okay, just like when we talk about probability of single events, now it's going to be about more than one thing happening at once. So, right here we have compound probability is the likelihood of two or more events occurring. First, we have three things that we need to do. First, identify the sample space. We can use a list, a diagram, a tree diagram, or a table. If order doesn't matter, cross out repeated combinations that differ only by order. Then number two, count the number of outcomes in the desired event. Remember, we have the formula is P equals to whatever you want to happen over here over the total possible things. Okay, we have that formula. Okay, so the number two will be on top and divide by the total number of possible outcomes, which will be number three right here on the bottom. Okay, we have a sample right here. A student spins a spinner, so we have a spinner, number 1 through 3, and enrolls a number cube. It does the same thing, both of them at the same time. Number cube is a dice, it has 6 numbers, 1 through 6. What is the probability that she will randomly spin a 1 and roll a number less than 4? Spin a 1, so we're looking for this right here, the 1. And on the spinner, on the dice, remember we have numbers 1, 2, 3, 4, 5, and 6. Correct? Now we created a table right here. The top is for the cube, for the dice, and the side is for the dice. And we're just gonna number the numbers on the dice and on the cube. Like just fill it in. Now, however, we need to emphasize that we need, on the number cube, we only need numbers less than 4. So which ones are those? Is 1 less than 4?
Yes.
Yes. What about 2?
Yes.
And 3?
Yes.
4?
No.
4 is equal to 4, and it just says less than 4. So we need to have what's going to happen when we fill it out, and the possible outcome is going to be divide the total number of possibilities. So we have 3 things right here, remember? And how many do we have on the dice? 6. So we have a total of 3 right here, and a total of what over here?
6.
And what do we do to get the total possible outcomes?
Multiplying.
Multiplying. So 3 times 6 is 18. And if you don't believe me, look over here. 1 through 6, 1 through 6, 1 through 6. 6 3 times is 18. And it's right here. Now, count the number of desired outcomes. What do we want? We want to spin a 1. So that can only happen on the first row. Right? On the first row of the spinner. Because this is the spinner right here. 1, 2, 3. We have 3 sides. We can only spin a 1. And we want numbers less than 3. So the only possible choice is spinning a 1 and rolling a 1. What we want to happen, to make it happen, to make it true, is spinning a 1 and rolling a 2, and spinning a 1 and rolling a 3. That's what we want to happen. That's what we're looking for. Anything else is not going to be what we want. Now, how many possibilities is that? 3 out of
18.
18, which is right here. Then the last step will be to simplify that, and that'll be 1/6. So the possibilities of spinning a 1 and rolling a number less than 3 will be 1 out of 6. Remember, first, find out the probability for the spinner, find out the probability for the dice, multiply those to get the total possible outcome, which is going to be the 18 right there. So we're going to find the probability for each event and then multiply it together. Now we have a few more examples right here. We have another table, and we're going to fill it out. It says, at a party, sandwiches are served on 5 types of bread. We have multi-grain, and they're going to create the table here for us, which is going to be the M. Pita, rye, sourdough, and whole wheat. Sam and Ellen, we have Sam and Ellen, and we have the same breads for both of them. Okay? Sam and Ellen each randomly grab a sandwich. Okay, they made different sandwiches and they each randomly grab one. What is the probability that Ellen gets a sandwich on pita or rye and Sam gets multigrain or sourdough? And it says right here what we need to do. Number one, the table shows the sample space. So right here, that is called the sample space. It says, draw an X in each cell which Ellen gets a sandwich on pita or rye. So right here, we look at Ellen. And these are the columns for Ellen. So we're going to draw an X, and we're doing it on blue. Pita, 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 and rye. That's all we're doing. That's all the possibilities for Ellen, right? And it says, draw a circle in each cell in which Sam gets a sandwich on multigrain or sourdough. Sam, multigrain or sourdough. So we're going to draw a circle. Multigrain, 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 or multigrain. Remember, he's in rows. And for sourdough, it's right here. Any questions on how to do this so far? We're just reading the columns for Ellen. That's why we went down. And the rows for Sam. That's why we went across. It says, count the number of possibilities that both have an oval and a rectangle, a circle and an X. Which ones repeat? Which one have both things at the same square?
Pita and multigrain.
Pita, multigrain, rye, multigrain. Sourdough and pita, and rye and sourdough. Everybody see? So we have this one right here. 2, 3. So how many times does that happen?
4 times.
4 times. Divide the number that you counted in step 4 by the total number of possibilities in the sample. How many possibilities do we have? We have 5 types of bread. Everybody agree? How many people do we have? 2. So it's going to be 5 times 5. 5 times 5. How many squares do we have in this space? 25. So it's going to be 4 out of 25. If we can simplify, we do it. In this case, we cannot. Now, this is the probability that Ellen gets a pita or rye and that Sam gets a multigrain or a sourdough. So they're just going to go in there grabbing a random. There's 4 out of 25 chances that they will get what they want. Any questions on this so far? That's it for today, guys. Have a good day.